Let's look at 4 rules for exponents and then a few examples. The first rule is the zero rule. This rule says that any non-zero number raised to the 0 power equals 1. So for example, x to the 0 power would be equal to 1 as long as x does not equal 0. The second rule is the negative rule. This rule says that any non-zero number raised to a negative power equals its reciprocal raised to the opposite positive power. So if you had x to the negative m, we would take the reciprocal, so we would flip that to be 1 over x to the positive m. The third rule is the product rule. The product rule says that when multiplying 2 powers with the same base, we keep the base and add the exponents. So if we had x to the m times x to the n, our answer would be to keep the base, x, and add the exponents, m plus n. The quotient rule tells us that when dividing 2 powers with the same base, we keep the base and we subtract the exponents. So if we're dividing x to the m divided by x to the n, we would keep the base, which is x, and we would subtract the exponents, m minus n. Now, we're going to use the acronym MADS to help us remember the product and the quotient rule. MADS means when multiplying, we keep the base and add the exponents. And when we are dividing powers with the same base, we keep the base, subtract the exponents. So multiply, keep the base, add the exponents. When dividing, keep the base, subtract the exponents. Let's look at a few examples. The first one we have 1 million to the 0 power. This would be equal to 1, right? Because any non-zero number raised to the 0 power is equal to 1. So this is equal to 1 because of the zero rule. Next we have 6 to the negative 2. Here we're going to use the negative rule. What we're going to do is we're going to take the reciprocal, we're going to flip this, so it's going to be 1 over 6 to the positive exponent. So not negative 2, but positive 2. 1 over 6 squared. And we know what 6 squared is, right? 6 squared is 36, so this would be equal to 1 over 36. 1 over 36. The next example we have a to the negative 7 b cubed. Let's write this using only positive exponents. So let's use our knowledge of the negative rule. Well, b here has a positive exponent 3, but negative 7, a to the negative 7, that's a negative exponent. So how are we going to get that to have a positive exponent? Well, we could use our negative rule and put that exponent in the denominator. And once we do that, it would go from being negative to being positive. So this b cubed will stay in the numerator. And in the denominator, what we're going to do is we're going to put the a not to the negative 7, because once it goes from the numerator to the denominator, it changes sign. So it goes from a negative to a positive. So b cubed over a to the 7th. Next we have 3y to the negative 2. Again, let's write this using only positive exponents. So how would we change the sign of y to the negative 2? Right now it's in the numerator. If I put it in the denominator, I will be taking its reciprocal, right? I'll be flipping y to the negative 2 to be y squared. So this is going to be 3 over y, not y to the negative 2, because once it goes from the numerator to the denominator, it changes sign. So it goes from negative to positive, 3 over y squared, because of the negative rule. Next example, we have 7 times 7 to the 6th. So we're multiplying with the same base, right? This exponent on the 7 could be 7 to the 1st power, right? Because when the exponent is not written, it's understood to be 1. So we're multiplying powers with the same base, so we can use MADS. This is the product rule. When multiplying powers with the same base, we keep the base, which is 7. So I'm going to keep the base, and I will add the exponents. 1 plus 6 is 7. So my answer is 7 to the 7th. Next example, we have 3 squared times 3 to the 18th times 3 to the 5th. Or again, we're multiplying powers with the same base, right? The base is 3. So I can use MADS. When multiplying powers with the same base, I keep that base of 3. I keep the base and I add the exponents. So 2 plus 18 is 20, and 20 plus 25, or 20 plus 5 is 25. So my answer would be 3 to the 25th. Next example, x to the 16th divided by x to the 9th. Notice that I read the horizontal fraction bar as divided by. So I am dividing powers with the same base. The base here is x, right? These powers have the same base of x. So I can use mads because mads I can use for the product and the quotient rule. When multiplying I would add, but I am now dividing, so I keep that base x and I subtract the exponents. 16 minus 9 is 7. So I get x to the 7th. Here I have 7 squared divided by 7 to the negative 8. So I'm dividing powers with the same base. The base is 7. I can use mads. When dividing, I keep the base of 7 and I subtract the exponents. When dividing, you subtract the exponents. So be careful here. This is 2 minus negative 8. If I'm subtracting the exponents, this is 2 minus negative 8, right? And we know that when subtracting a negative, if I subtract a negative, that's the same thing as addition, right? I could say to myself, slash, slash. So this is 2 plus positive 8, which is 10. That's my exponent. So my answer is 7 to the 10th power. Last example here, we have 2 to the negative 3 divided by 2 to the 4th. So again, we are dividing powers with the same base. The base is 2. So I'm going to keep that base in my answer. And because I am dividing powers with the same base, I can use mads. If I were multiplying, I would keep the base and add the exponents, but I'm not multiplying, I am dividing. So because I'm dividing, I would keep the base and subtract the exponents. So my exponents are negative 3 minus 4. Negative 3 minus 4. 3 is negative, 4 is negative. So I would say these have the same signs. I add and keep the sign. So 2 to the negative 7. But I want to write this using only positive exponents. So how could I get 2 to the negative 7 to be written using a positive exponent? Well, I can use my knowledge of the negative rule. Because 2 over 2 to the negative 7 is the same thing as 2 to the negative 7 over 1, what I can do is take the reciprocal. I can flip it. So this would be 1 over 2, not to the negative 7, because once the exponent goes from the numerator to the denominator, it changes signs. So it goes from a negative to a positive. So 2 to the negative 7, 2 to the negative 7 is the same thing as, or is equal to, 1 over 2 to the 7th.